Lecture 40, Multiple Integral Part 2. So take an example here. Here we have to evaluate the double integral over the some bounded region, which is a triangle here, which is a x equal to 0, y equal to 0, and x plus y equal to 1. So we have to evaluate that integral over that region. So you have to understand the limit of integration, because the limit of integration is not given, and we have to evaluate that integral in the particular region. So first we plot the region, and here you understand the concept of how to take the limit. So when we plot these lines, x equal to 0, that is y-axis, that's line, y equal to 0, that's line, and x plus y is equal to 1. When we plot that line, that's one, we can write y is equal to 1 minus x. So the region which is bounded, that's the region we have to evaluate that particular integral in that region. So here you have to understand the concept of the limit, and we can say the order of integration. So the region of the integration is what? Is in triangle. We can say O, this can say A, and this is B, and easily you find the point A and B by the help of that equation. Now you have to evaluate the integration. So first we put the limits. So here we take the strip along the y-axis. So we can say y varies 0 to 1 minus x. We can say y varies 0 to 1 minus x, and x varies 0 to 1. So the limit of integration is 0 to 1, 0 to 1 minus x. Integration e raised to power 2x plus 3y dy dx. So first we take the integration with respect to y, because the limit of integration of y in the terms of function was 0 to 1 minus x in the term of x, and the limit of x is 0 to 1, that is constant. So we take the integration, so we get 0 to 1, 1 by 3 e raised to power 2x plus 3y. When we take that integration with respect to y, treating x as a constant, dx. Now apply the limit 0 to 1 minus x, and on simplify we get 0 to 1 e raised to power 3 minus x minus e raised to power 2x dx. Now take the integration with respect to x here. So you get 1, that's 1 by 3 is also there, 1 by 3, 1 by 3 minus e raised to power 3 minus x minus 1 by 2 e raised to power 2x. Apply the limit 0 to 1. So we get 1 by 3 minus e raised to power minus 2, 1 by 2 e raised to power 2, and plus e raised to power 3, and plus 1 by 2 e raised to power 0 is 1. On simplify we get 1 by 6 e minus 1 whole square and 2e plus 1. On simplify we get this. So in that case we are taking the strip along the y-axis, and if we wish to want to take a strip along the x-axis, so in that case x varies 0 to, we can say x varies 0 to 1 minus y, and y varies what? 0 to 1. So you can also take this limit, it's depend the order of integration. So in that case, you take the integration first with respect to x, then y. So one more example, we have to evaluate the double integration. Y dx dy over the region is bounded by two parabolas, y square equal to 4x and x square is equal to. So first we plot this parabola. So here that's the equation of x square is equal to 4y, and that's a parabola y square equal to 4x. So this is an intersecting point, and easily you can get the intersecting point on solving these equations. So first simultaneously we solve the equation y square equal to 4x and x square equal to 4y. So on solving, you get x is equal to, if we put x is equal to 2 root y, so we get equation x is equal to 0 and x equal to 4. So here x varies 0 to 4, that's a point 4, and similarly y also we can say 0 to 4, and that's an intersecting point 4 and 4. So here x varies, we can say, if we are taking the strip along the y-axis. So y varies, that equation, that is 2 root x and up to the equation of this. So in that case, that's a y varies, that's the equation. So we can say y is equal to x, right, x square by 4, the equation of that curve, and the equation of this curve, the term of x is root 4x. So we can say x varies 0 to 4 and y varies x square by 4 up to root 4x. So now take the integration, you take the limit 0 to 4 x square by 4 up to root 4x y dy dx. So here first we take the integration with respect to y and then x. So what we get the integration 0 to 4 1 by 2 y square x square by 4 root 4x dx. On solving this, we get 1 by 2 integration 0 to 4 4x minus x power 4 by 16 dx. Now we take the integration with respect to x, so we get 1 by 2 and we get a limit 2x square. On integration we get x power 5 upon 80. Apply the limit 0 to 4, and on applying the limit we get 48 by 5. So in that way we can easily evaluate the integration. And if similarly you can take the limit integration, you take the strip along the y-axis. If you are taking the strip along the y-axis, so the limit of y is 0 to 4 and x varies root 4y up to y square by 4. So in that way you also evaluate that integration over that region. One more example, evaluate the double integration, the value of x plus y whole square dx dy over the region which is bounded by an ellipse. So here you see the ellipse, that's the equation of ellipse, and that's the ellipse. So if you are taking the strip along the y-axis, or you can also take the strip along the x-axis. So here we take the strip along the y-axis. So here you see the strip is vary from that to this point, and you know this point is what, minus a to a. So here first you solve that for the y. So you can write y square b square equal to 1 minus x square by a square, and this implies that y is, you can write y square by b or you write b square 1 minus x square a square, or we can say y is equal to plus minus b root 1 minus x square upon a square. So here or we can also write b upon a. If we take the LCM here, b a square minus x square. So we can say y x varies minus a to a, and y varies minus b by a root a square minus x square up to b by a square minus x square. So these are the limit of integration. If we are taking the integration along the y-axis, means first we take the integration with respect to y, then x. So minus a to a and minus b by a square minus x square, b by a square minus x square, x plus y whole square dy dx. And when you evaluate that integral, so we get in value pi by 4 ab a square plus b square. You can easily solve that integration. You just expand this x square plus y square plus 2xy. So here this is an even function and that's an odd function. So you use the property of integration even and odd, and then apply the limits minus a to a and evaluate. You get pi by 4 ab a square plus b square. So next example, double integration y dx dy over the part the plane bounded by the line y equal to x and y square equal to 4x minus x. So here that's in curve y is equal to 4x minus x square, and that's a line y equal to x. So first you find the point of intersection. So that is the region of integration. So here you have to evaluate that integral. So again we take a strip along the y-axis, you also take the strip along the x-axis also. So here the limit of the x is what? So you can easily find that point. You just substitute y equal to x in that equation. So you get x equal to 3 and y equal to 3. So x here, x is vary 0 to, you can say 3 0, that is 0 to 3, and y varies x up to 4x minus x cube. So in that way you can easily evaluate the integration. Limit of integration is 0 to 3 and y varies x to 4x minus x cube y dy dx. So first you take the integration with respect to y, then with respect to x, and you get result that is 54 by 5. You can easily evaluate. Please do yourself. So in that example, you have to evaluate the integration x square dx dy in the first quadrant bounded by the curve xy equal to 16, x equal to y, the line y equal to 0, and the line x equal to 8. So if you plot that graph, so suppose that's in xy is equal to 16, that's the line, and this is the y equal to x line, and this is what? This is y equal to 0, and that is x is equal to 8. So the region which is bounded by these lines or a curve is that's one. So you have to evaluate the integration, that integral in that particular region. So here when you're taking the limit of integration, so first you have to divide that particular region in two parts. So here this, so we get the two regions here. We say that's an O, and we take this is A, that's in B, this is C and D. So here, because when you're taking the strip here, if you not divide that particular region in two parts, so you cannot take a strip because when you take the strip here and that strip is expanding, so after that point it will be changed. So you cannot get the region by taking the single strip either with respect to y or with respect to x. So here first we divide that complete region in two parts. So here we get two regions, O, A, B, that's in triangle, and the second region is what? B, A, B, C, T. So the complete region is what? O, B, T, C is what? The triangle O, A, B plus A, B, C, T. That's in region. So here we have to find the limits in that region. So when we take the region OAP, and if we take the strip along the y-axis, so we can say x varies from 0 to, and you easily find that point, that's an intersection point of this and this curve, and we get that is 4 4, and that point, the integration of the intersection of that line and that curve, we get this is what 8. So that's an 8 and 2. So we can say for the first region the x varies 0 to, that is that point is what 4 0 0 to 4, and in that region y varies 0 to that, the equation of that line is x. And when you take the region A B C D, so we can say x varies, now the x varies from that point to that point, that is 4 to 8, and y varies here, that is 0 to up to that curve. So what is y here? Y is equal to, we can write 16 by x. So in that way you can easily evaluate that integral. You take the, break that integral into regions, that is double integration OAP plus double integration ABCT. Continue in the next lecture.